Hello again. So in the last video we looked at 4 of these 8 standard graphs, and I forgot to mention something. So just a quick note, that graph of y equals e to the x, that's called an exponential graph. Exponential. And the other one, natural log of x, that's called a natural log graph. So exponential graph, y equals e to the x, natural log graph, y equals the natural log of x. So let's meet these other 4 graphs. What could they be? You've met this one before. Label the axes. This one's got 2 asymptotes. Here we have the line, well that's the line where x equals 0. And let's pop the other one in. Of course I'd be using a ruler. That's the line where y equals 0. Alright, the curve goes something like this. And something like this. In fact, I'm going to do it again because that's not quite perfect. Okay, something like that. There we go. Making sure we're not touching the asymptote. Alright, what's that graph called? It's called a hyperbola, and its equation is y equals 1 over x, or we could say y equals the reciprocal of x. I want to be a bit fancy. Y equals 1 over x, and that's our parabola. Sorry, that's our hyperbola. Alright, let's have a look at our next one. Similar sort of family. This one has the same asymptotes here and here, except it's slightly different. Not touching there, it's not touching, see it's not touching. And if I drew that better, that would be symmetrical. There we go, that's a truncus. That's y equals 1 on x squared. So that's our truncus. Alright, next graph. Well, we've got 2 more. So what could we be missing? Well, we've done a parabola. We've done a cubic. We've done an exponential function. We've done a natural log function. We've done the truncus. We've done the hyperbola. So this one's going to be slightly new, but it's nothing to be afraid of. We have to learn what this new symbol means. So if you ever see 2 lines on the outside of a number like this, this is called the absolute value. So here I'm taking the absolute value of -3. Absolute value means take the size of the number and ignore the sign. So forget about the minus sign. Absolute value always spits out a positive answer. That's what the absolute value does, and it's denoted by 2 lines. So another example might be, let's say we've got -1 minus 2, and we want the absolute value of that. Well, -1 minus 2 is -3, and the absolute value of -3 is 3. Okay, so now we've met the absolute value. Well, there's an absolute value function. And it looks like this. It's y equals the absolute value of x. So just like your line, just like your linear graph, which will go like that, the graph of y equals x, the absolute value function does that as well, except this side is going to be positive. So this side's going to be up here. because all those negative x values are going to give positive y values because of the absolute value function. So let's do that. So pretend I'm using a ruler. So that's a straight line, and it's going to hit the origin, and then it's going to go straight back up. Alright, so let's do that a bit straighter. It's going to go straight back up. And that point there is, of course, 0, 0. And that is what the absolute value function looks like. So let's write that in. Absolute value function. Okay, so we've got one more graph to go, and if I can just find my notes on it, I'll find out what one I decided it was. Ah, yeah, good. Okay, this graph looks like this. Starts here, it pops out like that, and that's the point 0, 0. So it's like part of a parabola but flipped on its side. And that's the graph of y equals the square root of x, which we should be familiar with. And that is the square root function, or square root graph. Are there any other graphs? No, we've covered our 8 graphs. So in the next video, we're going to look at describing dilations, so stretching them or pushing them in, reflections, flipping them around, and translations, which are moving them around. So we're going to look at the language we need to describe moving and stretching and flipping these graphs around. And if you have been, thanks for watching.